Hello. Today I want us to look at how to evaluate the integral of 1 over x cubed plus 1 with respect to x. So what we do, we need to be able to factorize the denominator. So we need to know how to write x cubed plus 1. Remember, x cubed plus 1 is gotten from the binomial expansion of x plus 1 cubed. So we are going to expand x plus 1 raised to 3 is the same as x cubed plus 3x squared plus 3x plus 1, binomial expansion. So from here, I can take x cubed plus 1, and then the rest you take to the right-hand side. So this will be to the left-hand side. So make x cubed plus 1 the subject. So this implies that x cubed plus 1 should be equal to x plus 1 cubed minus 3x squared minus 3x. And this can be written further as x plus 1 cubed. You see 3x is common, so 3x common. Here we'll have x plus 1. You can also see x plus 1 is common. So you factor out x plus 1 to get x plus 1. Then inside we'll have x plus 1 squared minus 3x. So when I square x plus 1, we'll have this x plus 1. Inside the other bracket, we'll have x squared plus 2x plus 1, then minus 3x. And you simplify this further to get x plus 1. Then we'll have x squared minus x plus 1. So that x cubed plus 1 can be written as a product of x plus 1 and x squared minus x plus 1. So our integral, we rewrite this integral as the integral of 1 over x plus 1 times x squared minus x plus 1 dx. So look at our denominator. We have a product of two functions of x. To be able to evaluate such kind of integrals, we use partial fraction decomposition. So we are going to say let 1 over x plus 1 times x squared minus x plus 1 be equal to a over x plus 1 plus bx plus c over x squared minus x plus 1. We are using partial fraction decomposition. You know the rules of partial fraction, that if the denominator is linear, then the numerator must be a constant. If the denominator is a quadratic factor, then the numerator must be a linear, which we are calling bx plus c. So a, b, and c are constants to be determined. How do we find them? So I'm going to cross multiply this equation by the LCM to get a times x squared minus x plus 1 plus bx plus c times x plus 1 should now give us 1. I have multiplied both sides by the LCM. So I can call this equation star, so that, we need to find the values of a, b, and c. Now, how do we find them? There are two methods. The first method, you could expand everything on the left-hand side and then equate the coefficients of the corresponding, or simply the corresponding coefficients, left and right-hand side. Another method, which is easier, I want to choose some values of x that will help me eliminate some constants or some terms in this equation star. So if you look at our equation star, if I put x is equals to -1 in equation star, that will help me eliminate the second term. So this will give us a -1 squared is 1 minus -1, which is simply plus 1, plus another 1. The second term will be 0 is equals to 1. So when you make a the subject, you get a is equals to 1 over 3. You make a the subject to get 1 over 3. So I still remain to find the values of b and c. So again, choose any other value of x. So you can say again, if I put x is 0, remember the starting value must be such that it will help you eliminate some terms. That is the hint in this method that we are using. So when I put x 0, what will I get? In the same equation star, I'll get a times 1, which is just a, plus c, because b will be, there's b times 0, which is 0. So plus c is equals to 1. But I know a to be 1 over 3. So 1 over 3 plus c is equals to 1. So what do you think is c? You make c the subject, that will give us 2 over 3. Choose any other value to represent x. We always use smaller values because it's easy to work with smaller values than bigger values. So we can also put x is equals to 1 in equation star. That will give us a, because I have 1 squared minus 1 plus 1, that is just 1. So a plus, I can see when x is 1, I will be having b plus c times 2 is equals to 1, which you can write as a, but you know the value of a plus 2b plus 2c equal to 1. So replace a and c. This means 1 over 3 plus 2b plus 2 times c, that is 4 over 3, should be able to give us 1. Or this can be written as 5 over 3 plus 2b is equals to 1, which means 2b is the same as 1 minus 5 over 3, that is negative 2 over 3. And so when you divide by 2, you get b is equals to negative 1 over 3. So we have found the constants a, b, and c. So that means that our integrand can now be written as, this one. So therefore, this integrand now becomes the integral of, look at our partial fraction, a over x plus 1. Our a is 1 over 3. So 1 over 3, let me write that in a better way. One over 3 over x plus 1, that is a over x plus 1, then plus b. Our b is negative 1 over 3x, and our c is 2 over 3. 2 over 3, remember this negative 1 over 3, I can also write that in a better way. Just a minute. So that is b, which is negative 1 over 3. It was bx plus c, and our c is 2 over 3. And then this is over x squared minus x plus 1. The all of this you integrate with respect to x. You see 1 over 3 is common. Factor out 1 over 3. So 1 over 3 outside, times the integral of 1 over x plus 1. Then I can also factor out, make the coefficient of x to be positive. So I can write this as negative x minus 2 over x squared minus x plus 1. Integrate with respect to x. And so using the property of integrals, this integral can be written as 1 over 3 times the integral of 1 over x plus 1 dx minus 1 over 3 times the integral of x minus 2 over x squared minus x plus 1 dx. I can split the second integral further as, let me write it down. This can further be written as 1 over 3 times the integral of 1 over x plus 1 dx minus 1 over 3. You see, this integral can be written as the integral of x, or simply I can write that as 2x minus 4. I've multiplied the numerator by 2, so I must also divide by 2. Then over x squared minus x plus 1 dx. So this you can also write as 1 over 3, the integral of 1 over x plus 1 dx, minus, so that will now give us 1 over 6. 1 over 6, the integral of 2x minus 4 over x squared minus x plus 1 dx. I've just opened the bracket. Now, the second integral still can be written as, let me write everything. So this is the same as 1 over 3, the integral of 1 over x plus 1 dx, minus 1 over 6. That integral can be written as, because you know that 2x minus 4 is the same as 2x minus 1 minus 3. So this you can write as the integral of 2x minus 1 over x squared minus x plus 1, the dx, of course, that dx. Then there's that minus 3. So minus the integral of 3 over x squared minus x plus 1 dx. So you can see what I've done there. I have split the numerator as 2x minus 1, then another one will be 3 minus 3. So when I open the bracket completely, this can now be written as, 1 over 3 times the integral of 1 over x plus 1 dx, then minus 1 over 6 times the integral of 2x minus 1 over x squared minus x plus 1 dx. I'm opening the bracket. This 3 is a constant which can be factored out, so it will be 1 over 6 times 3, which is 2 over, not 2, but 1 over 2. So, and it is a plus because there's a minus and another minus. So that will be plus 3 over 6, which is the same as 1 over 2 times the integral of 1 over x squared minus x plus 1 dx. So now it is easy to integrate. Let's see what we had on the left-hand side. It was the integral of 1 over x cubed plus 1. So to integrate this will give us 1 over 3 natural log of x plus 1. What about the other one? Minus 1 over 6 natural log of x squared minus x plus 1. In the first two integrals, you use substitution so that you get the answer that I have gotten. In the first one, u will be x plus 1. In the second one, you let u to be x squared minus x plus 1. But in the third one, what will be the answer? We have to, so plus, I can put a question mark. Because I need to tell you how to find the third one, the third integral. So, now look at this integral. We need to take note that x squared minus x plus 1, if we complete the square, can be written as, let me write this, that x squared minus x plus 1 is the same as x squared minus x plus a number c. We are completing the square, then plus, remember there was 1 minus the same number c, so that we don't interfere with the original form. And c here is the same as b over 2 squared, where b is the coefficient of x. So that's negative 1 over 2. You square that, that should be able to give you 1 over 4. Negative 1 over 2 squared, that is 1 over 4. So this is the same as x squared minus x plus 1 over 4, then plus 1 minus 1 over 4. So when you factorize the first bracket, you get x minus 1 over 2 squared. Then 1 minus 1 over 4 is the same as 3 over 4. So now this integral of 1 over x squared minus x plus 1 dx is the same as writing the integral of 1 over x minus 1 over 2 squared plus 3 over 4 dx. So this is the form of the integral where the integrand is 1 over a variable squared plus a constant squared. And we said in that case, you let that variable to be tan theta. So you're going to say, let x minus 1 over 2 to be equal to a tan theta. Our a here is root 3 over 2. So a tan theta. So what about dx? So therefore, when I differentiate, I get dx is equals to root 3 over 2 sec squared theta d theta. So when I make this substitution, then it means our integral will now be equal to, we are now substituting, that is now 1 over x minus 1 over 2 squared. That will give us 3 over 4 tan squared theta. Then I can see there's another plus 3 over 4. And dx is the same as root 3 over 2 times sec squared theta d theta. And if I simplify this, 3 over 4 is common in the denominator. So I can see this root 3 over 2 in the numerator divided by 3 over 4 in the denominator times sec squared theta d theta over tan squared theta plus 1. And you see tan squared theta plus 1 is the same as sec squared theta. So this can be written as root 3. That's the same as root 3 over 2 divided by 3 over 4. So it's the same as root 3 over 2 times 4 over 3. Root 3 over 2 times 4 over 3. The integral of the theta. And so when you simplify, you get 2 root 3 over 3 theta. And when you replace theta, make theta the subject from here. From here, you can make theta the subject. If I multiply by 2 over root 3, I'm going to get this 2x minus 1. I'm multiplying by 2 over root 3 being equal to tan theta. So from here, make theta the subject. So get theta is tan inverse of 2x minus 1 over root 3. So that our answer here will now become 2 root 3 over 3 times tan inverse of 2x minus 1 over root 3. So go back to our final answer. I will go back to this question mark. Question mark, remember it was 1 over 2 times the question mark, which we now know the answer. So it is this answer here that we are going to substitute into the question mark. Substitute there so that we get our final answer. So it's 1 over 2 times the answer that we have found. So you see the 2 in the denominator will cancel with the 2 in the numerator. So therefore we can say that, therefore, let me write this down. So we can say that, therefore, the integral of 1 over x cubed plus 1 dx is the same as, what did we get in the first term? It was 1 over 3 ln x plus 1 is the same as 1 over 3 ln x plus 1. Then I can see there's a minus 1 over 6 ln x squared minus x plus 1. So let me write minus 1 over 6 ln x squared minus x plus 1. Then there's 1 over 2 times the answer here. So that will give us plus root 3 over 3 tan inverse of 2x minus 1 over root 3. Then there's a constant c of integration. And you see, you also need to take note that root 3 over 3 can also be written as, if I multiply both sides, both numerator and denominator by root 3, I am going to get this 3 root 3. So that root 3 times root 3 is the same as 3. So that is 3 over 3 root 3, which you can write as 1 over root 3. So instead of root 3 over 3 is the same as 1 over root 3. So this is how to integrate 1 over x cubed plus 1 with respect to x. Thank you for watching. Next time we look at other forms of integrals or other problems where you are required to evaluate the integral.